Get that page out. And remember, we're supposed to limit our cell phone stuff.
What one is it on?
Last week. It should be in last week's folder. Alright, so we did 1, 2, 3, 4, 5. Agree?
6, 7.
That's what we looked at. Working through this. Alright. Alright, so alright, it says for the following function, give the intervals where it's increasing, decreasing, give the maximums. So, all right. So, when it says give the intervals, I'm not too worried about us finding the interval versus doing it on the sign chart, the plus and minuses. So the first thing that we have to do on this particular type of problem is we have to kind of see if we can break this down. So I'm going to set that equal to 0 over to the side. And I need to figure out where it's equal to 0. So it's like, how do I even do that? Well, the math is goofy, but it will work out nicely to where I get down to this. And that's kind of nice to try and break that down. And then you could take the x squared minus 4x, you can bring an x out front. And then you have x and x minus 4, and that's equal to 0. So this is going to say that x equals 0, and this is going to be that x is equal to positive 4. Okay? So those two particular values are where it would cross the x-axis, which is fine. But if we wanted to figure out like kind of a derivative thing to this, we could just draw our, well, hey, how you be? Like you sure? So basically, these are where we have solutions that are taking place. Now, the nice thing is those solutions could tell us, where it's crossing the x-axis. So if we were to look at this, if we kind of thought about making ourselves a line where we have 0 and we have 4, basically what's happening is a couple things could take place. I could come down to the 0, I could bounce off of it, okay, which that goes from being a decreasing to an increasing or vice versa. But as we work through this problem, we can just start taking some values to think about. So remember, I want to figure out a value very far to the left, very far to the right, and somewhere in between. So I don't know, we might be able to say, hey, negative 10's down here. That would be pretty easy to plug into this particular equation. So if I took negative 10 and plugged it in, I'm going to get negative 10 squared, which is 100, and then plus 400. Well, it's 400. I don't care what 400 squared is, but I know that that's positive. So over here, this would have been a positive slope that was taking place. And then if I wanted to think about somewhere in here, like pick a value between 0 and 4, well, I think 1 would be a pretty nice number to pick, to plug in. You can say, okay, if I plug 1 in, I get 1 squared, which is 1, and then negative 4 minus 1 is negative 4, so 1 minus 4 is negative 3. If I square a negative number, I get a positive. So this is a positive here as well. So what theoretically took place in between, or to the left of 0 and to the right of 0, like right at 0, what's taking place? Max, min, or point of inflection? Point of inflection, yeah. And then I'm going to pick a value over here, like say 10, plug it in. If I plug 10 in, I get 10 squared minus 40, that's 60, 60 squared. That's also positive. So, friends, help me out on this problem. What in the world? How do I go positive to positive to positive? That's kind of weird. So this doesn't have any relative mins or maxes. It doesn't go and change direction. If we look at this on the graph, that's going to be pretty goofy, but for the most part, we can show that we have some sort of increasing function, that something weird happened. So, I'm not even sure what that graph would look like. And I don't want to go on Desmos right now and figure that out. All right. Okay, clear? No?
No.
Okay. I'll take a sip of coffee then. You ready now?
Yeah.
Alright, so let's take a look at this. So we want to find the roots, we want to find the f prime chart, intervals increasing, decreasing. Again, I feel that this, the increasing, decreasing, these are both answered when you look at that. So I don't think we have to worry about it. And then we can figure out where max and mins are at. So if I wanted to figure out the roots to this, we could graph it, plug it in, or we could say, well, I know that factors x minus 4 and x plus 3, or x plus 1, excuse me. If I FOILed that out, I'd come out to that. So this is going to give me the root at x equals 4 and x equals negative 1. And then I'm going to go 4 and, oops. Negative 1 and 4. And so let's try and build upon that, what's taking place. So I need to pick a value to the left of negative 1, a value between negative 1 and 4, and a value to the right of 4, and plug them in and see what types of things would be taking place. So if I took negative 10 and plugged it in here, that's giving me 100, and that's giving me minus 30 minus 4. So 100 minus 30 minus 4 is still positive, so it's positive here. I might want to pick 0 because 0 would be really easy to plug in there. That's going to give me a negative 4, so we have a negative there. And then if I wanted to pick a value to the far right over here, because everything that's taking place on this problem is happening basically between 1 and 4 as far as the major curves. So if I took 10 and plugged it in, 10 squared is 100. 100 minus 30 minus 4 is still positive. So this basically means that you had a positive slope here, a negative slope here, and then we had, this is still negative slope here, and then it does something like that. So we can kind of think about what's taking place at negative 1 because of that picture, a max or a min. Max, right? So I have a max at negative 1. And then if I took a look at the same picture and I came to here and said, oh, what's taking place at 4 if I was coming down on the left side of it and going up on the right side of it? Well, that means a minimum would have taken place at 4. And then what do I think my graph might look like? Well, I don't know. I could go negative 1 here. I could go 4 over here. And I could say, hey, this is kind of coming up, and then it's coming down. Then it starts coming back up. So this graph could look something like that. And again, that's not the exact version. where this is showing where our max is taking place. And we don't know exactly what the max is, and this is showing where the min is taking place. It's just we're using it to go through and just get something in our mind of what it might look like. So that, again, that F prime chart is important to kind of look at because it's talking about the slope at specific points, which is great. Well, hello. Gotcha. Thanks. Oh, Tati.
Bruh. Oh my gosh.
You got a Starbucks gift card.
Don't read it.
It doesn't say anything. I don't know why they fold it. Ding. Can I clear? All right. Number 8. So find the roots, F prime chart, decreasing, increasing, again, decreasing, increasing. We take care of with our F prime chart, it shows the same thing. So this shows the same thing as what that's going to show, so I don't think it's necessarily due. So if I wanted to figure out the roots of this, I'm going to set it equal to 0. And then what I can do is I can factor an x to the third out here, and that's going to give me this. And if I said x to the third equals 0, if I took the third root of both sides, third root of 0 is also 0, so I get x equals 0 is 1. And then set that equal to 0, so x equals 4. So if we take a look at our chart, we're going to have 0, and we're going to have 4. So again, we want to try and figure out where things are increasing or decreasing, what's taking place at 0 and 4. We can build upon that. So I'm going to take a look and I'm going to say, okay, I'm going to pick a value to the left of 0, so again, I'll pick negative 10. So if I take negative 10 and plug it in here, negative 10 to the 4th power is a big positive number, and then this is going to be another pretty big positive number. You have two positive numbers, so over here it's a increasing graph. Between 0 and 4, we can plug 1 in. So 1 to the 4th minus 4 to the 1 to the 3rd. So I'm going to get 1 minus 4. So here it's negative. And then if I come over here and pick, a value like 10, to plug 10 into it, I get 10, 100,000. I get 10,000 minus 4,000, which is positive. So as our signs change, something is taking place here. So this would be kind of a positive thing. Then it goes to a negative thing. And then it goes down here as a negative thing, back up to a positive. So this is going to give me a max here. This is going to give me a min here. So I have a max at 0, and I have a min at 4. And that's the name of the game as far as these go. Holy moly, guacamole. Good stuff. Everybody happy? Woo. All right. Clear? Sip of coffee, then clear? All right. All right. Determine the roots. I don't know if I want to have that first problem done. I'm gonna skip that top first problem. And we're gonna look at this. Okay. Okay, so there's specifically two different things, and they're kind of done by the same notion when we're plugging these in. Notice they gave us the derivative of number 2, and then number 3, they gave us the original function, but they're asking for the exact same thing. So what we truly could do with the F prime chart is if we take a look at, if we take a look at this top one. Clear. So this is already a derivative. Now we don't know how to do an antiderivative to get the original function, but we can work from that. So let's see what a few things might take place. Let's take a look at the zeros here, and this is not a 0, this is an undefined term when we plug -3 in. So let's think about a few things. So x squared is going to lead me to 0, so that's x equals 0, that's 1, and I'm basing this off the derivative. X minus 2 equals 0, so that's going to give me 2. And then at x plus 3 equals 0, this is going to give me -3, and this is undefined. So this is an asymptote. Okay? So we're going to base our F prime off of this, and then what we actually have to do to number 3, and I think I might have goofed up, but we'll figure it out in a sec. So if I figure out my F prime chart based on this, I have -3 here, I got 0 here, I got 2 here. So because we have an undefined term, that gets a little goofy. So that basically means I have a vertical asymptote happening at -3. So we have to think what's really happening. Like there's possible that the asymptote does this and this on either side of 3, or it could come up straight up and go straight down. So we have to figure both of those out because there's something that's interesting that takes place there. So if I take the -10 and plug it in, so if I take -10, which is over here, and plug it in, see what's happening to the left of -3, I'm going to get 100, and then that's -12, so 100 times -12 is a negative number, and then on bottom I get negative. So basically over here, this is negative that's taking place, so we have to think about what this original graph might look like based on the derivative. If I take -1 and plug it in, and think about what that's doing, if I take -1, plug it in, I get -1 squared, which is 1. Guys, I asked you to put your phones away. If you don't like it, get out. I'm not going to get written up because you couldn't be off your phones. If you don't like the policy, go drop the class. I'm kidding. I'm not kidding. Just guys, it's when my job is based on if a kid has a freaking cell phone, that's ridiculous. But I refuse to get written up because you, the student, chose not to be paying attention in class. It's disrespectful. If you don't like it, go drop my class. I'll make sure it's a withdraw, not a withdrawal F. I mean, I'm serious. It's horrible. Don't do this to me, please. I'm a great person, and I hate having to be the bad guy, but keep them away. Okay? I mean, that's the only thing that I got docked on my evaluation. And for the most part, when I was evaluated, most of you had it out, but she still picked up on people on phones. So she comes in and says, oh, look, those kids are on their phone again. I mean, I have to show that I'm doing something to prevent it, even though it's an impossible endeavor, unless we say everyone's cell phone goes up here in this thing, and then you put the burner up there and you keep your cell phone off to the side. You know, it's ridiculous. Can I get back to my story, or this? Okay, -1 plugged in here. -1 squared, 1. 1 minus that is negative. I multiply those together and I get a negative number. Down on the bottom, I get over a positive. Negative over positive is negative again, so it's negative in between here. If I pick 1 and see what's taking place, we can do the same thing. So 1 squared, 1 minus 2 stays negative on top, on bottom stays positive. We got like a bunch of negative things taking place here, so we got to see what's taking place there, and then maybe pick 10, plug it in. 10 squared is 100, times 98, it's a big positive number, over 13, which is a positive number, so finally get a positive. So here, I have a min that's taken place, but then I have this taking place here, but I have to realize this is an asymptote. So how does this asymptote take place? So this is going down, and this is going down. So basically, this graph, if we had to speculate what it would look like, at -3, it's probably doing this. And that's what the original graph would look like. Not the derivative graph, but the original graph. And then we would have something that would come over and do this. Something like that. It's kind of a weird graph. Not sure where you'd see that in the real. Okay, now, took care of the sine graph there. Let's take a look at this, and this is where I think I goofed up. Let me take the derivative first, and I might have to go back to those, or maybe we could just save ourselves here. So I'm going to get to there. That's the derivative, agree? All right, let's solve the derivative. So I'm going to get 15x to the 4th minus 15x squared equals 0. So this is going to just give me x equals 0, and this is going to give me x equals 1 and x equals -1, because if you factored x squared minus 1, that becomes x plus 1 and x minus 1. So we're going to base our derivative graph on this. So let's focus on these two problems for the rest of the assignment. Let's take those last ones that we just did, kind of set them to the side for a bit. All right, so -1, 0, -1, or +1. Those are our values. All right, so if I take -10, which is way over here, and I plug it into here, that's going to give me a big positive number minus a smaller number. So over here it's going to be positive. And it's like, well, what do I do between -1 and 0? I don't really have a number. Well, unfortunately on this one you have fractions. So if we were to take 1/2 and plug it in, 1/2 to the 5th power times 3 is a tiny fraction. Okay, so if you think about 1/2, so 2, 4, 8, 16, 32, this becomes 3 over 32 minus 5 over 8. Okay, what's the bigger fraction there? And that becomes the thing that you're just not sure about. So if you go 3 divided by 32 on a calculator, you get a small decimal. If you go 5 divided by 8, you get a little bit bigger one. So this is a smaller number minus a bigger number, which means that has to be negative. And that's kind of a little trick to play on that one. And then if I take, that was plugging 1/2 in, wasn't it? So this was negative. I did the 1/2 here. I need to make sure I plug a -1/2 in there. So the -1/2 is going to come the same way, so that's going to be negative, and that's going to be positive. So then I get a negative small plus a little bit bigger number, so that's going to be positive here. And then if I pick, say, 10, plug it in, that's going to be a really big number minus a number that's smaller, so that's going to be positive. So I have a negative to a positive, so that gives me a min. And then I have a positive to a negative, that gives me a max. And then I have a point of inflection that took place there. So give all max mins for the following. That goes through. Okay, so my min happens at 1. My max happens at 0. And then if you wanted, you could say I have a point of inflection that takes place at -1. So base these problems off of that we're going to do from here on out. You just look at 2 and 3 as 2, 3, and 4 as examples. to go through it. Okay? There's kind of a lot there, but good thing we work together. Any ideas? I'm going to lose a little perfume cap, I think. Ooh, I'm feeling funny. All right. So, clear? All right. Would you guys,
Ooh,
ooh, what?
smells like alcohol.
Yeah, it was that perfume cap I just tossed.
Oh.
What was it sniffing on? That's right. Oh, and I put hand sanitizer on. So, would you focus on those? And I guess we will go over those on Monday.